Hello everybody, I am Reshma Lakshmanan, Division of Electronics Engineering, CUSAT, Kerala, India. First of all, I would like to thank IEEE Plus 2021. Today I am going to present novel compact flexible chipless RFID tags. Next is introduction. Chipless radio frequency identification tags are popular in recent times because of their low cost compared to chip-based counterparts. Various chipless tags with variety of structures and features are presented in literature. They mainly differ in the shape of resonators, number of bits, and the nature of substrate on which the tags are printed. L-shaped resonators are presented in 9, where it may result in unsymmetrical bending performance. Chipless RFID tags with high bit capacity, fabricated on extremely thin flexible substrate, is presented in this paper. Main applications are identification, tracking, and sensing. Next is development of tag. Figure shows the tag 1 and tag 2 geometry. The U-shaped slots are made on 30 by 33 mm flexible substrate. Tag 1 is made by arranging these 8 slots in a cascaded fashion. In tag 2, alternate sets of 4 slots are in one half of the substrate, while the remaining in the other half. These are the dimensions of tag 1 and tag 2. Next is chipless RFID reading mechanism in CST, in which reflection of linearly polarized plane wave incident on the tag is collected by a receiver probe to obtain the RCS response of the tag. Next is simulation results. Figure shows the RCS response of tag 1 and tag 2, in which 8 unique resonances with distinguishable separation between the resonant frequencies in the frequency range 3 to 9 GHz, and the 8 frequencies are noted here. Next is surface current density distribution of tag 1 at 3.2 GHz and at 5.2 GHz. Next is surface current density distribution of tag 2 at 3.2 and 5.2 GHz. These are the fabricated prototype of tag 1 and tag 2. Next is flexible wideband RFID reader antenna operating in the frequency range of 2.35 to 9.3 GHz. These are the measurement setup. The experiment setup consists of vector network analyzer, 2 wideband antennas, and a tag under test. First figure is bistatic arrangement for reflection, and next is for transmission. Next is measurement results. Figure shows the measured ST1 response corresponding to bit pattern. First for reflection response of tag 1, and next is transmission response of tag 1. Next is measured ST1 response of tag 2. First one is reflection response and second one is transmission response. Next is flexibility studies. RCS response of the tag needs to be evaluated under bending conditions. Use different radius cylinders to emulate different extents of bending. Tags are bent on cylinders with different radii. Next is image of horizontal bend on cylinder and RCS response of tag 1 under horizontal bending with different radii. Next, image of vertical bend on cylinder and RCS response of tag 1 under vertical bending with different radii. It can be inferred from the flexibility studies that horizontal bend is more stable than vertical because of the horizontal symmetry of the slots. The tags are found to be stable up to a bending limit of 20 mm radius. Next is measured transmission response under horizontal bending of tag 1 and tag 2. Tags are placed on a foam material and bent through a radius of 30 mm. The ultra-thin property of the tag material, symmetrical geometry, and sufficient gap between the slots make the tag stable under the situations when it is curved. Next is conclusion. U-shaped slot resonator-based chipless RFID tags covering wide band for identification applications proposed. 2 tags with same structure and different slot orientation is presented for 8-bit applications. The RCS response reveals that the tags are generate 8 unique identification codes in wideband with adequate separation. Experiment using bistatic method has been carried out to assess the response of reflected signals. The flexibility study shows the validity of 8 bits even under different bending radii. Horizontal bend is more stable than vertical because of the horizontal symmetry of the slots. The bending stability makes them suitable for sensor applications where substrate bending is unavoidable. Next is acknowledgement. These are the major references. Thank you.